Hello, everybody, and thank you for joining us for this session of Vertica Unify 2021. Our next breakout session is entitled Running Containerized Vertica with Kubernetes StatefulSets. I'm Paige Roberts, Open Source Relations Manager at Vertica. I'll be your host for this webinar. Joining me are three experts from Vertica, Amit Saha, Principal Product Manager, as well as Principal Software Engineers Ning Deng and Matt Spilchin. Before we begin, I encourage you to submit questions during the virtual session. You don't have to wait. Just enter your question into the Q&A box on the right-hand side of the screen. There'll be a Q&A session at the end of the presentation, and we'll answer as many questions as possible during that time. Any questions that we don't address, we'll do our best to answer offline. Alternatively, you can visit the Virtual Developer Lounge to ask additional questions and to continue the conversation with our engineers and product experts after the session. And yes, before you ask, this virtual session is being recorded and it will be available to you on demand this week. We'll send you a notification as soon as it's ready, so please stick around. At the end, for the code that will help you gain points to participate in our Analyze to Win competition for prizes. Now let's get started. Over to you, Amit.
Thank you, Paige. Hello, everyone. My name is Amit Saha, and I'm a Principal Product Manager here at Vertica. Today, we are going to talk about how you can run Vertica in a Docker container and orchestrate it using Kubernetes StatefulSets and Vertica Kubernetes operator. So let's begin. Here is the agenda for today. We will start with understanding the basics of containers and Kubernetes. Then we will get into Vertica specific details, the features, architecture, and technical deep dive into our implementation. We also have a cool demo for you, followed by Q&A at the end. So let me start with a little story. It was the year of 1956. And an entrepreneur in North Carolina in US named Malcolm McLean was pondering how to move cargo in an easy, cheap, and efficient way between New Jersey and Texas in the South. And he finally came up with this idea of buying World War II containers and tankers and use them to carry goods. The key idea was very simple. It should be easy and cheap to load, unload, stack, and transport across different modes of transport, ships, rails, trucks. And that's how physical container became very popular in US, right? So a container is something that makes it easy to move. Kubernetes is a Greek word which means a pilot or a helmsman, and they are responsible for steering or managing the ship which is carrying the container. So what do container and Kubernetes mean in the software world? A container is a unit of software that packages up all of your code and all its dependencies, okay? And think of it like your favorite meal kit, which has everything to prepare your dinner. Containers are lightweight compared to VMs because they share the OS kernel. And like the McLean's physical containers, they are easy and cheap to transport across private, hybrid, and public cloud. And Kubernetes is the pilot that manages these containerized workloads. By manage, I mean deploying, provisioning, scaling up and down, checking health, etc. Right? And we will get into more details later in the presentation. So why have containers and Kubernetes become popular? What we have seen that during the last couple of years, two trends have emerged in the container market. One, the container runtime has become the lowest common denominator to run workloads across physical machines, private cloud, and public cloud. And this is very similar to how physical containers enabled intermodal transportation, which you saw in the previous slide. And the second trend is that Kubernetes has become the de facto control plane for managing the containers. And one key reason of why organizations are adopting containers and Kubernetes is because they are increasingly adopting microservices within their enterprise architecture. So what are the benefits of using a container and Kubernetes? Based on the latest CNCF survey, improved scalability, shorter deployment time, and improved availability are the top reasons why organizations are going for containers and Kubernetes. Another interesting trend we are seeing is that more and more containers are being used for stateful applications like databases. And at Vertica, we also have been hearing the same story from our customers. Our customers have been using containers for their stateless applications for some time. Now they love the scalability, better availability and portability of containers. And now they want the same consistent approach to deal with stateful applications like Vertica. We listen to our customers and we are very excited to announce support for Docker containers and open source Kubernetes with Vertica. Essentially, we will support 4 key things. One, we will have 2 types of official CentOS-based Docker images. One is optimized for Kubernetes use, and the other one will contain Vertica Community Edition. And both the images will be hosted in Docker Hub. And all of our Kubernetes codes, including StatefulSets and operator, will be open sourced and put in our GitHub. Second, we are supporting StatefulSets, which is Kubernetes' way of dealing with stateful applications like Vertica. And to support this, we have to do some optimizations like re-IP support. And Ning will get into more details into next part of the presentations about that. Third, we will have a Vertica Kubernetes operator. And we have built this operator in Go. We have followed the operator SDK framework, which is proposed by Red Hat. And what it does, it makes your life as a Kubernetes admin super easy. So you could do automated install, restart, scale up and scale down of Vertica nodes. You could create automated databases, and you could do all the Eon mode subcluster operations, create subclusters, start and stop subclusters automatically using this operator. And Matt has a cool demo where he will get into more details into each of these use cases. And lastly, we are also supporting Helm, which is a Kubernetes package manager. So instead of you typing kubectl 10 times into your terminal, you type one Helm command and your Vertica cluster is up and running. These 4 things are available today. You could go to our Docker Hub and GitHub, and I'll show you in a short while, and you could try this today. In fact, we also have a beta version of our operator, which is available in our GitHub for you to try. But please remember that the operator will be generally available in our 11.0 release. So here is a snapshot of our Docker Hub page. Let's say you are just getting started in your containers and Kubernetes journey, okay? And you just want to quickly spin up a Vertica cluster. So what you do, you go to Docker Hub in this particular link, then you type Vertica in the search bar here and you come to this page and then you select the appropriate Docker image. So like I said, you will have one image for the Vertica Community Edition. And what you do is you go to this Docker pull command, this section, and you click on this portion so that you could copy the entire Docker pull command. And then you open up your favorite terminal. In my case, I have opened a PowerShell, and then you paste that Docker pull command. So you can see here that I pasted that Docker pull. And what this is doing is your Vertica Docker image is being downloaded into your local machine. And then the next step you do is you do Docker run and then either give the name of the image or image ID. And that's it. Your Vertica container is up and running. And now if you want to use your favorite SQL statements or use your favorite vSQL, which you have been using with Vertica, you have to get into the Docker container. And I have not shown this in the slide, but what you do is you use the Docker exec command to get into the particular Docker container, and then you start writing your SQL statements. It's super easy, 3 steps. Do a Docker pull, download the image, do a Docker run, your Vertica cluster is up and running, and then do a Docker exec, get inside the Docker container and start writing your SQL queries. All of this can be done less than 5 minutes. So please go ahead and give it a try. Would love to get your feedback and comments here. And this is our GitHub page where you will see all of our operator and our Helm charts and all the YAML files. And also, let's say you don't want to use our Docker image, but you want to build a Docker image of your own. So you will find all the Docker files here. So you use that Docker file and do a Docker build to build your own image. And then you can use it with our Kubernetes operator. And Matt will show you the demo and you could see in details. So with this, I will now hand it over to Ning to take you through the rest of the presentations. Ning?
Thanks, Amit, for the introduction. So, to run Vertica in Kubernetes, the first topic we would like to discuss here is the IP addresses of Kubernetes pods and Vertica nodes. In Kubernetes, pods are the smallest deployable units. Vertica containers run in pods and will use the IP addresses of those pods. That is, Vertica nodes will be using the IP addresses of the pods. IP addresses of Kubernetes pods are ephemeral. That means pods are often being recreated with new IP addresses. For example, if a pod crashes or is deleted, the newly created pod in its place most likely receives a new IP address. However, Vertica assumes static IP addresses of nodes. So, to run Vertica with Kubernetes, we would like to support Vertica nodes to start up with new IP addresses, such that if a recreated pod receives a new IP address, the Vertica node running in that pod can join the cluster with the new IP address. There are, in general, 2 cases where we need to start up Vertica nodes. The first case is that the database is up and we just need to start up down nodes. The second case is that the database is down and we will need to start the database. That is, start all the nodes in the database. We will go through those 2 cases one by one. For the first case, starting up down Vertica nodes with the new IP address when the database is up, we introduce a new option called New Host IPs for Vertica admin tools command, restart node, where Vertica admin tools is a tool that can be used by DB admin users to perform administrative tasks for managing their databases. The basic syntax is listed in the slide. To use the new option, one would need to specify at least a database name, a comma-separated list of Vertica node names in the --hosts option, and a comma-separated list of new IP addresses to assign to the specified nodes in the new host IP option. The restart node command will first update the IP addresses of the specified nodes in the catalog, and then update and distribute config files around many admin-tools.conf and spread.conf to use the new IP addresses of the nodes. Finally, because the IP addresses of the nodes are updated everywhere, the command now can start up the specified nodes, and the nodes can join the cluster with the new IP addresses. This new option is Kubernetes specific and lightweight. It does not delete or create catalog directories and data directories of nodes. This is different from the existing admin tools command called db replace node. We do not touch those catalog directories and data directories because in Kubernetes, pods can use persistent volumes for storage. In our case, it means that the catalog directories and data directories can be stored in persistent volumes, and they will not disappear even when the pods of Vertica nodes are being recreated. Therefore, there's no need to delete or create those directories. Also, this command does both re-IP and restart for nodes, which can help simplify steps that will need to be performed by users, scripts, or Kubernetes operators to start nodes with the new IP addresses. As for the second case, that is, starting up down Vertica nodes with the new IP addresses when the entire database is down. So in this case, the existing admin tools re-IP command and startdb command can be used. In the admin tools re-IP command, one can first prepare a map file that maps all the IP addresses of all nodes in the database, or just a subset of the nodes in the database, to new IP addresses. And then the re-IP command will update the IP addresses for those specified nodes everywhere, according to the entries given in the map file. Finally, admin tools command startdb can be used to start the database. Both re-IP and startdb are existing admin tools commands, and they have good documentation, so we do not discuss more details of them here. Admin tools commands can be used in different ways in Kubernetes to manage Vertica databases. And using Kubernetes operator is one of the best ways. A Kubernetes operator manages a Kubernetes application automatically. Next, we will be introducing Vertica Kubernetes operator. The Vertica Kubernetes operator internally uses admin tools commands to manage database. It is designed for Vertica EON mode. It uses operator SDK framework. It is written in Go language and is namespace scoped. It is also open source. The open source code is available on Vertica GitHub repo, and the link is listed here. Before we get into details of Vertica operator, I would like to briefly go through Vertica Customer Resource Definition, that is CRD. Customer resources are extensions of the Kubernetes API that allows adding a customer resource to the Kubernetes cluster. In our case, Vertica database can be viewed as a customer resource. That means, in our case, Vertica CRD contains necessary configuration for deploying a Vertica database, including container image configurations such as the image name and the image pool policy. Vertica EON configurations such as the shard count, data path, and also subcluster configurations like subcluster name and subcluster size. Vertica operator watches Vertica customer resources defined by the Vertica CRD and takes specific actions to manage the database. Specifically, we mainly have the following actions being automated in our Kubernetes operator. install and uninstall Vertica, create a Vertica database, scale up and scale down, which includes creating subclusters and removing subclusters, adding nodes and removing nodes. Also, restart nodes, subclusters, and the Vertica database. But we also have health props, and we have even more. I will hand it over to Matt for an overview of the Kubernetes operator architecture and a cool demo.
Thanks, Ning. So before I dive into the demo, I just have a quick slide here that shows the overall architecture of Vertica and Kubernetes. A Vertica node corresponds to a pod. Each pod has a persistent volume attached to it. The persistent volume stores the config, the local catalog, and the depot. Now, it doesn't store the communal storage. That storage isn't included here because it doesn't need to be in Kubernetes. As long as we have an endpoint that's accessible from a pod, we don't care where it is. The pods themselves are controlled by a stateful set. We'll have one stateful set per subcluster. Each subcluster has a service object that load balances across the pods. This picture only shows a single subcluster, but if you have multiple subclusters, you can envision another stateful set and a set of pods created for it. So I'm going to demo the operator. I'm going to show how to deploy the cluster and to be able to connect to it through VSQL. So you'll see me use K a lot on the commands that I enter. This is just an alias for the kubectl command. So my setup. So I'm running a Kubernetes kind cluster. The only thing that I have running is min.io. Min.io stores the communal data for Vertica. So there's no requirement they need to run min.io. Any S3 compatible endpoint will do. I only use it because it's easy to spin up Kubernetes and makes this demo a bit easier. So you can see the min.io pod running. So the first thing you need to do is deploy the operator. So the operator itself runs in a deployment object. We have a Helm chart that you can run to install this deployment. For this demo, I'm just going to run the Helm chart from a local Git repository, but the Helm chart will be available in Vertica's public chart repository. So let's get the Helm install command and run it. You can see it comes back fairly quick, and if you do get pods, you can see there's a pod now for the operator. Currently only one of two containers are running. Second one should be up momentarily. There it is. So both are up. So now we have the operator, and it has a watch on our custom resource definition. And that's the next part I'm going to talk about. So I'm going to show you what a bare minimum, what you need to have in your custom resource. We have a lot more options in this, but this is what you need to have as a minimum requirement. So you need to specify the S3 path. You need to specify the endpoint to be able to connect to it, and a secret. So the secret contains the access key and secret key to be able to connect to the endpoint. And then you need to have at least one subcluster defined. So I have SC1 here defined with the size of 1. So let's go ahead and apply this. On the right, you'll see on the top right are the events from the operator, just to indicate what it's doing. And the bottom right are the Kubernetes objects that have been created by the operator. So you can see in the events that we make reference to pre-existing Vertica commands. So if you're already familiar with these, you could have a good sense of what's going on. And you can see that we're already in the middle of creating a database for this new cluster. You can see that we have a stateful set for the subcluster, a service object for the subcluster, and one pod that corresponds to the size of the subcluster. So you can see that the create database was successful, took 35 seconds. And at this point, we have our cluster's up and running. We're only a few minutes in, and we already have a running cluster. So the next thing I want to show is scaling. So the size that we set in the custom resource is not static, and we can add more pods. And there's a couple ways to scale. So I'm going to show the first way is by adding a new subcluster. So let's edit the custom resource. In here, we have a subcluster list. And to add a new subcluster, you simply add a new entry to this list. Let's add a subcluster, call it SC2, give it a size of 1. And go ahead and apply this. You can see on the right that we've created a new stateful set for the subcluster, a new pod that goes along with it, and a new service object. In the events, you can see that update Vertica is being called for this new pod, and this is just to set up the config for the pod so that it can talk to the other pods in the cluster. So one thing to point out here is the ready probe that we have for the pod. The way that we use this for our operator is it's an indication of where the Vertica process is running. So as you may expect, at the start of a scale out, Vertica is not running, so you can see that the pod's not up, not ready. And this just means if you're connecting through the service object, it's not going to write to the down pod, and that's kind of what you want. All right, so the update Vertica was successful. Now it's in the middle of calling db add node, and this is to start up the Vertica process. And you'll see that the ready probe gets triggered usually sooner than when the db add node is successful. So you should see that change fairly soon here. There it is. So the new pod's now ready. And you can see that the db add node was successful. So now we have a second subcluster here that we can connect to. The other way to scale is to increase the size of an existing subcluster. So I'm going to show that. So let's go and edit our custom resource, and you can see the size field. I'm just going to change SC1 from 1 to 2 and apply that. You can see a new pod's already been created. And again, the ready probe on it is not triggering for obvious reasons. And so if any traffic is routed to SC1 here, it's only going to get routed to the pod that's already ready, the one that was added before. So we're calling update Vertica on this new pod, again, just to set up the config so it can talk to the other pods in the cluster. While we're doing the scale out, one thing to point out is the status information you can get from our custom resource. So we include status columns when you do kubectl get. You can see here that we list out the number of subclusters, the number of pods that have been installed, the number of pods where we've added the database, and the number of pods that have the Vertica process running. This last field, auto restart Vertica, is just a state for the operator to tell it whether it can restart Vertica if it's not running. So the db add node was successful. Sorry, the update Vertica was successful. So the install count goes to 3. Now we're in the middle of db add node here to start up Vertica on this new pod. Not quite ready yet, and that should trigger fairly soon. Just want to point out the subclusters were added as primary. There's an option within the custom resource where you can create them as secondary. Let me just edit the custom resource to show you. You can see there is primary field. You can change that to false. You get a secondary subcluster. I'm not going to change that here though. All right, so the add node was successful. All pods are up. Now we have a 3-node cluster across 2 subclusters. Now, a demo won't be complete if I didn't show a restart scenario. So one of the things that the operator can handle is automatically restarting down nodes. Or if you lose quorum, the entire cluster can be restarted. So let me delete one of the pods, one from SC1. You can see that the new pod that I deleted has already been rescheduled and is running again. But for obvious reasons, the ready state is not yet triggered because Vertica is not running in this new pod yet. So there's a bit of a delay in starting the pod. So Kubernetes knows the pod is down, but we have to wait until Vertica comes to the same realization. So there are timeouts for spread in Vertica that need to expire before you're able to restart the node. And that's what we're waiting for now. That's why you don't see any events in the operator indicating that it's restarting the node. So we're just going to wait for those to expire. And while we're waiting, I just want to point out that the operator is namespace specific. It will only monitor custom resources that are modified in the current namespace. So if you plan on having multiple namespaces, you will need to deploy this operator multiple times. So you can see that the restart node now is running. So the spread timeouts have expired. And so now we're able to call that admin tools function to restart Vertica. This takes about a minute or so to run. So one of the things that restart needs to handle is new IPs. So Vertica communicates with other nodes in their cluster via IP address. So when a pod is rescheduled, it gets a new IP assigned. So part of the restart process is updating this new IP in Vertica so all nodes know how to talk to it. And that's all handled automatically. So we're nearing the end of the restart. It should finish soon. You should see, you can see the new pod's now ready. So the new command, yeah, there it is. The restart node has completed successfully. And so now we're back up and running. So the next thing I want to talk about is client connectivity. So we have a service object for each subcluster. And by default, the type is cluster IP, which gives you a load balancer for internal Kubernetes traffic only. So for this demo, I want to open up to outside access so that I can run VSQL from my laptop. To do that, I'm just going to set up the service type to be node port. And to do that, it's fairly easy. You just edit the custom resource. And I'll show you how that's done now. Let's edit the custom resource. You can see in the subcluster section, we have service type. You just change that to node port. I'm just going to, for this one, I'm going to assign a node port number so that it's known. And I'm going to apply that. You'll see the operator has already changed the service type there. So now, and there's a port. So if I run a simple VSQL for my laptop, I should be able to connect. I'm just going to do a simple connect. There you go. So the next thing I want to talk about is the load balancer. And so I have a query that I'm going to run that it'll just print out the node name and that subcluster that it connects to. So I run the same query against the same endpoint. It will change to a different node. It's going to take a couple tries here. You can see the last one, it connected to node 1. The other one's connected to node 3. So this is the connection are being load balanced across the two pods in the subcluster. So the next thing I want to talk about is a revive. So when I created the custom resource, I didn't specify how to initialize the database. By default, it will create a new database, but you can set it up instead to revive from an existing endpoint. So this allows you to migrate an existing database into Kubernetes. So this is what I'm going to show next. But in order to make it interesting, I'm going to populate some data in the cluster so that it can query back after the revive is done. So I have a very small data set for the Major League Baseball 2012 season. It's just 30 rows, one row for each team is just going to show the payroll and wins. So let me just ingest that data and I'm going to query back so we can have a look at it. And see there's 30 rows, one for each team with their payroll and the wins. So I'm going to sync this data to the catalogs because I'm going to shut down the cluster very soon. Now, in order to create the custom resource for this new revive data, we have a tool called VDB-Gen. And what it'll do is it'll generate a YAML that you can then apply if you want to move an existing database to Kubernetes. So I'm going to run it against the subcluster that we've created, and it'll print out a YAML that you can then apply if you wanted to revive that database. And the key here is that the init policy is set to revive. So let me just run this tool again. We're going to save this to a file called revive.yaml. Now I'm going to go ahead and delete the current cluster. This just deletes the Kubernetes objects. The communal data is still there. So you can see the objects went away. Now if I apply the revive YAML that we just saved, the objects will come back. You can see we have the same set of objects. They have slightly different name because we gave it a new name. And you can see that the operator is calling update Vertica. So it needs to set up the config on all 3 of these pods so they all can talk to each other. This process takes about a minute or so to run. So I want to mention too, in our custom resource that we just applied, we set ignore cluster lease to true. This is for demo purposes only. You wouldn't want to use that in a real database that you want to revive, as it could lead to data corruption. But it just simplifies the demo here. This VDB-Gen tool that we created, it's available in our GitHub repository. It's a Go binary. So once you get access to it, you can run it against your own setup to see what custom resources it generates. So you can see that the update Vertica was successful across the 3 pods. Now it's proceeding to call revive DB. This command is relatively quick here. It takes about 20 seconds or so to run. So we'll see this complete soon. There it is. So at this point now, the local catalog's been copied to each of the pods. And so the next step, you can see that Vertica is not running on it yet. All the ready probes are off. So you can see the operator is now calling start DB on this new cluster to start up Vertica process. So I'm going to change back the node port because I want to set it up for outside traffic. This didn't get preserved because it's not a state in Vertica. It's a Kubernetes state. So I need to change the node port back. And the start DB is almost finished. You can see the ready probes already triggering. Okay, so the start DB is done. So let's issue the same query that we had before. We should see the same data. There you go. So it's the same data as before. So just to prove that the revive worked. So that's all I wanted to show for this demo. Thanks for watching. And I'm gonna turn it back to Amit.
Thanks, Matt. That was a super cool demo. I would highly encourage all of you to try the Vertica operator. Like Matt showed in the demo, the operator will make Vertica deployment super easy and it will make your life super simple, right? So please do give it a try. And if you have any questions, catch us during the Q&A session. All right. So we have a lot of exciting things which are coming in the future of Vertica, Kubernetes, and containers. We are just getting started. Like I showed you in the feature slide, we are now supporting 4 key things: container image, supporting StatefulSets, supporting the operator, and the Helm charts. Moving forward, we like to think our progress in 2 dimensions. So one which I like to call depth and the other which I like to call breadth. So what do I mean by that? By depth, I mean that we will add more capabilities into our operator. So if you look at the operator framework, which is proposed by Red Hat, there are 5 levels. Level 1 is install, level 2 is update, level 3 is backup restore, like that. And in this release, we are only tackling level 1, which is automated install. So as we move forward in our journey, we will add more capabilities and we'll tackle different levels. So that is what I mean by depth. What is breadth then? So breadth is adding different flavors of Kubernetes. So for example, right now, we are supporting open source Kubernetes, but there are different public cloud flavors. For example, EKS from Amazon, AKS from Azure, GKS from Google, as well as the private cloud option, OpenShift, Rancher, Tanzu, HPS Merrill. So we will continue to add more and more different types of Kubernetes based on the interest and your feedback. And lastly, storage is a big part of your whole Kubernetes architecture. And it becomes more important with database and with the architecture like Vertica in Neon mode, where your compute and storage are separated. So right now, you have option of provisioning storage using static provisioning, which comes with Kubernetes. But going ahead, we will also work, and we are already working with our partners like Pure Storage to support dynamic provisioning. And Portworx is probably the first thing that we want to support, where if you want to run Vertica in your environment, and you have Portworx already in your environment, you could use Portworx to provision and configure storage, which is needed for Vertica in Neon mode. So a lot of exciting features which are coming, and please give it a try. Let us know your feedback. We would love to hear from you, and I know we are super excited. And with this, I will hand it back over to Paige to lead the Q&A session. Paige?
Thanks, Amit. If you want to learn more after this conference is over, remember that our Vertica Academy is always available for free on-demand training and certification. Now we are ready. Let's launch into the Q&A. All right. So the first question I have is, will the Docker Hub repo be in sync with the Vertica releases? So Amit, I think that might be a good one for you.
Yeah, I can take that. So we are very early in our journey of Docker Hub. We are just getting started. Our goal is definitely to be in sync with the Vertica release, and that is what we plan to do. Yeah.
Okay. All right. So during your demo, Matt, it seemed like the secondary subcluster was slower to create than the whole database. Is there some plan to optimize that?
Yeah, it's something we can look at in the future. It just wasn't something we optimized for the first release, but it is something we can look at.
So it'll get better as time goes on. Gotcha. All right. The other question is Eon mode required? I think that's back to Amit there.
Yeah, sure. Yeah, so you need to be on Eon mode for you to try out, Vertica in Kubernetes. The main reason because we chose this architecture is Eon mode is very much in sync with the principles of Kubernetes. So yes, you need to be on Vertica and Eon mode to try Kubernetes and to get the full benefits that come with Kubernetes.
Ning, Matt, is there something you'd like to add? Either one?
No, I think you summarized it good.
All right. Yep. Let's see here. Does the operator support... Whoops, something switched around here. Oh, that's what I was about to ask. Does the operator support creating a Vertica cluster with IPv6? Ning? Do you want to take that one?
The answer is yes. So basically, our operator will check the IP addresses of the Kubernetes cluster, and then when it sees that it's IPv6, then it will be like creating a IPv6 Vertica cluster. So the answer is yes.
Okay. All right, that makes it easy. Let's see. Oh my goodness, we've had some more come in. Let's see. The demo that you did, someone had a request to see the file that you used to do that, Matt. So maybe you could supply that after the presentation?
Yeah, sure, definitely can do
that. Is Azure Cloud an option for running pods with Vertica? Amit?
So right now, our plan is to start with S3 or S3 compatible storage. We have mainly tested S3 compatible on-prem object storage. But like I said, as we go along, we will support different versions of cloud-based Kubernetes, including AKS. And we will also expand the dimension of supporting different types of storage. So absolutely, yes, going ahead, we'll also support Azure Blob. Just that we also launched the GA of Eon mode with supporting Azure blob storage. So that is already there with 11.0, and we have that. We'll have that GA, and we will extend that capability to Kubernetes environment as well as we go along.
Thank you, Amit. Okay, I'm not sure who I should pass this one to, but it's asking about the default affinity strategy and can it be configured? Who would be best?
Yeah, so we don't, the operator doesn't have any opinions on that, but the affinity can be set, and other things like a node selector, and, I think a few other ones. But yeah, you definitely control where your pods are scheduled, but it has to be specified in the CR. We don't have any, we have no defaults for that.
Okay, good to know. How do you handle scaling down critical subcluster nodes on a small cluster? I assume it means scaling down like primary nodes.
It works just in the opposite way of doing the scale up. Like you can shrink the size of the subcluster, like you can reduce the count of the subcluster, or you can remove subclusters entirely. And it uses the usual admin tools commands to perform that.
Good. One more came in. With the Vertica Kubernetes operator, can workloads be separated automatically and start-stop automation for efficiency?
Yeah, like we provide service endpoints for each subcluster that clients can connect to. That's about as much as we can do for automation.
So maybe I can add a little bit. So we are supporting Eon mode, and Eon mode you could have primary and secondary subclusters, right? So the whole idea of a subcluster is workload segregation. And the way we are exposing one subcluster is you will have one service endpoint uh, for each subcluster. So as long as you have something on top of your service, can be some kind of load balancer that you use, which can route traffic to different subclusters to this service endpoints, then you could use that mechanism to do workload isolation using one subcluster as well. Just wanted to add that.
All right, we're running low on time here. Someone put in not a question, but thanks for Vertica on Kubernetes. So that goes to all three of you, I'm sure. Let's see. I think I covered them all. There was a bunch of them, so I kind of got lost there. I think those are all of them. And now I want to just say thank you guys for giving us lots of good questions, lots of good interactivity, being a great audience. If we weren't able to answer your question, if I missed it in there somewhere, be sure and either maybe we can get back to you online, or you can go talk to the developers directly at the developer lounge. And they'll be there to answer your questions. Now, a replay of today's event and the PDF copy of the slides will be available on demand shortly. You can feel free to share those with your colleagues. And don't forget to do the Analyze to Win. Go to the section, Analyze to Win section on the event navigation panel. Choose this particular session on Kubernetes and enter the code for this session, which is Boston Terrier. That's our code. So that's what Boston Terrier, the whole thing. And right after this, be sure and stay tuned for a word from our gold sponsor, Scality.
Control your entire platform, regardless of scale, easy with the new Artesca UI. Wouldn't you love to get a bird's-eye view on overall health of your data and management tasks? Create access points for as many use cases and apps as you like to run. Manage all storage devices from core to cloud to edge to tape, and all of your data centers, nodes, and volumes. Vertica, a cloud-native, fully containerized solution on Kubernetes. From scaling data to the art of scale. Scality.